Assalamualaikum, my name is Zulfakri from MEB2 with ID number 18002384. As for my lab 2 fluids mechanics, I'm going to present an experiment entitled Bernoulli's theorem demonstration. Bernoulli's principle states that if a non-viscous fluid is flowing along a pipe of varying cross-section, then the pressure is lower at constrictions where the velocity is higher, and the pressure is higher where the pipe opens out and the fluid stagnates. And the principle is expressed with following equation, which is P over rho G plus V squared over 2G plus Z equal to H star, which is equal to constant. So P is fluid static pressure at the cross-section, and rho is density of the flowing fluid, G is acceleration due to gravity, V is mean velocity of fluid flow at the cross-section, and Z is elevation head of the center at the cross-section with respect to a datum, and H star is the total stagnation head. The objective of this experiment is to investigate the validity of the Bernoulli equation when it is applied to a steady flow of water. So the experiment is conducted by using an apparatus that consists of venturimeter, manometer tubes, test section, water inlet, unions, air bleed screw, flow control valve, gland nut, hypodermic probe, and adjustable feed. And here is the procedures for the experiment. First step is to set up the apparatus as the figure shown, and the second step is the discharge valve is adjusted to a high measurable flow rate. Next is after the level stabilized, the water flow rate is measured using volumetric method. Next step is the hypodermic tube, which is the total head measuring connected to manometer G, is gently slide so that its end reach the cross section of the venturi tube at A. So wait for some time and the readings from the manometers are noted down. Steps 2 to 4 are repeated with different flow rates. So the difference between two calculated velocities are determined by using Bernoulli's equation and using continuity equation, and the comparison between the two velocities are discussed and recorded in the table. As for the calculation, first we calculate the area of tapping point by using the formula pi over 4d squared, and we got the value is 5.309 exponent negative 4 meter squared. And as for the velocity of water by Bernoulli's equation, we calculate by using the formula 2 times G times H star minus H square root. So the value of the velocity of water is 0.3431 meter per second. Next, we calculate the velocity of water by continuity equation. So the value we got is 0.2697 meter per second. Next, we calculate the average ideal flow rate, and the value we got is 1.432 exponent negative 4 meter cube per second. And here is the result table. So as for the experiment, for the volume of the fluid we use 5 liter, and the time taken is 24.47 seconds, and the flow rate is 1.432 exponents negative 4 meter cube per second. And here is the result for different cross section, which is A, B, C, D, and E, F. And and here is the value for the result by using Bernoulli's equation and continuity equation. And we can see that from the difference, the percentage error for A is the smallest, and the percentage error for F is the highest. Next, we move on to discussion. So there are large values of percentage errors and the significant difference in values between the velocities calculated using the Bernoulli's equation and continuity equation. And from this experiment, we can analyze that the smaller the diameter, the higher the pressure difference and velocity produced. And this is obey the Bernoulli's principle, which stated that the higher the velocity of the fluid, the lower the pressure. In conclusion, the objective of the experiment, which is to validate the Bernoulli's equation, is achieved. So the velocity of the fluid in a manometer can be calculated by using both Bernoulli's equation and the continuity equation. And the errors of the experiment can be reduced by preventing the apparatus from leaking and make sure no air bubbles are present. That's all from me. Thank you.